everybody? Welcome to another video. Hope you're ready to flex those brain muscles. Today we're going to talk about quadratic functions, and we're going to find the roots or zeros or x-intercepts. They all mean the same thing, whatever you want to call it. This is what we're going to learn to find in this video. I'm going to call it roots. I don't really want to list out 3 names every time I refer to it, so we're going to find the roots of some quadratic functions. So hopefully you know a little bit about quadratic functions, that they are of this form, ax squared plus bx plus c. And since a root is just the x-intercept, what do? We set y equal to 0 and we solve for x, right? And hopefully you've done this at least a little bit by factoring, or maybe use the quadratic formula or completing the square, however you want to do it. But I have some videos up here if you don't know what this is about, and maybe you should check those out first. But let's go ahead and get into it. So what are our possibilities? We have 0 roots, 1 root, or 2 roots. And what this means is basically our solution to this, we can either have 0, 1, or 2 solutions, okay? So the best way to make sense of this, in my opinion, since these are x-intercepts, is to draw a little graph. So I'm going to draw, this is the y-axis, this is the x-axis. So x-intercept means this graph intersects with the x-axis. That's how I remember it. So if we have 0 roots, that means this graph, which by the way is a parabola, a U-shape. Hopefully you've heard that word before. But yeah, it's a U shape, and for it to not intersect with the x-axis, what has to happen? Well, the vertex has to be above the x-axis and open upward, right? Or the vertex has to be below the x-axis and open downward. And again, these can be shifted left or right, or even down or up or whatever, but both these things have to be true. It's either above the axis, opening upward, below the axis, opening downward. That has to be true for there to be 0 roots. So I'll write 0 roots. Okay, what about 1 root? And maybe you're already seeing, maybe you're already predicting what's going to happen here. And if you are, then good for you. That's awesome. Okay, so for 1 root, what has to be true? Well, the only way to have 1 root is if my vertex is on the axis. So I can be like somewhere here and open upward. And again, it doesn't matter which way I open in this case, actually. Or I could be here and open downward. Regardless of where I open, the only way to have 1 root, to have 1 solution, I drew this one so bad, I'm so sorry. The only way to have 1 solution is for the vertex to be on the x-axis, right? So the third case is by far the most common when we have 2 roots. And you probably already know what that's going to look like. If not, I will quickly sketch it. So, same idea, we have our x and y axis. And in this case, what's going to happen? If we're above the x-axis for our vertex, I'll use a different color since we're color coding this. If we're above the x-axis, if our vertex is above the x-axis, what has to be true for us to have 2 roots? We'll have to have 2 intersections with the x-axis. So that means if I have some vertex up here, it has to open downward. And if I have some vertex, let's say down here, it has to open upward. Alright, and this is by far the most common possibility of 2 roots. Usually that's what you'll see, 2 roots. But 1 root and 0 roots are possibilities as well. So let's go ahead and do some examples. Okay, so before we continue, it would be a shame if we were trying to find the roots of a quadratic function that turned out to not have any roots, right? We'd be basically trying to solve this for x, but there's no real solution. We're trying to solve something that's basically unsolvable. We're wasting our time, right? So there is a little shortcut, there's a little trick, and we can use this shortcut to identify which of these 3 categories, whatever quadratic function we're dealing with, falls into. Okay, and that saves us a little time, so we're not trying to find the solutions of something that doesn't have any real solutions, okay? And the best way to see and kind of understand this shortcut is to look at the quadratic formula and relate these 3 possibilities to the quadratic formula. So hopefully this looks a little familiar. Basically, we plug in a, b, and c to this, and we get our 2 solutions for x. So how can we get 0 roots? That means that we have no real solution to this. That means both of these x values, negative b plus all this stuff over 2a, and negative b minus this all over 2a, both of these values are complex numbers, right? Because we have no roots, no real solutions. So b is a real number, a is a real number, and 2 is a real number. So the only way both of these can be complex is if this square root of b squared minus 4ac is complex. And that's pretty easy to see because if we ever have a negative under a square root, that's not a real number. So how can both my solutions for x be complex? Basically, I have no real solutions. Well, that's if b squared minus 4ac is negative. So we have 0 roots if b squared minus 4ac is negative, so less than 0, okay? So what if b squared minus 4ac is greater than 0? Well, then we have a real number here, a real number here, and a real number here. We have 2 roots, 2 solutions, right? So b squared minus 4ac is greater than 0, then we have 2 roots. Okay, now the only case we're missing is when b squared minus 4ac equals 0, so you can probably tell that that's going to go in here. But think about it, if this equals 0, this term just kind of drops out, and we're left with negative b plus 0 over 2a, and negative b minus 0 over 2a, and that just simplifies to negative b over 2a. We just have one solution, right? So if b squared minus 4ac equals 0, then we have 1 root. So we can kind of use this to help us before you try to solve something, maybe use this. And this, by the way, is called the discriminant. That's real important, the vocabulary, right? This is called the discriminant. So if the discriminant is greater than 0, 2 roots. If the discriminant equals 0, 1 root. If the discriminant is less than 0, 0 roots. And you can use this before you're trying to find the roots just to make sure you know how many roots there will be. It helps a little bit. So now we'll get into some examples. Okay, so we're given this example. Maybe first you could try to factor it, but the first thing I would personally do is use that discriminant to find out how many roots we're really dealing with here. So I'm going to go ahead and do that. So what is it again? B squared minus 4ac, right? So what is my b? My b is negative 3. So I have negative 3 squared minus 4 times a is 1 and c is 4. So I have minus 4 times 4. What does this come out to? Negative 3 times itself, that's 9. Minus 4 times 4, that's 16. 9 minus 16, what is that? Negative 7. Uh-oh, we have a negative, right? Do you remember what that means? That means there's actually no roots, okay? So there's actually, if I set this equal to 0, there's no real solution. And you'll probably quickly see that you can't factor it. And then you'll put it in the quadratic formula, and then you'd get complex answers. But this is a nice little shortcut. We can immediately tell this has no roots. Okay, so just so we're clear on that last example, I should have wrote no real roots because there are still complex roots. So I apologize. Don't shoot me. There are no real roots, okay? A lot of professors are picky about that. So moving on, let's go ahead and jump straight into this next example. Again, I'm just going to use the discriminant. I'm going to find out how many roots we have here. Maybe your professor or teacher does it differently. They don't use the discriminant on every example. But for the sake of this video, and well, let's just go ahead and do it. I like to know how many roots I have. I mean, you know, this is how I do it. B squared minus 4ac. All right, so what's my b? Negative 12. So negative 12 squared minus 4 times 9, okay? Negative 12 squared is 144 minus 4, let's see, 4 times 9 is what, 36 times 4, 72. Oh, that's 144. This gives me 0, right? What did we say when we have a discriminant that equals 0? That means there's 1 real root, right? 1 real root. And I'll give you a big tip, a big hint, and this is true anytime you have a discriminant that equals 0. You have 1 real root, and what else is also true is that this can be factored, and this is a perfect square trinomial, so it can be factored into 2 binomials that are identical. And we'll see what this means in just a second. If you don't know what that means, that's okay. I'll prove it to you. I'll prove that this can be factored into some binomial squared. So I'm going to use the AC method. So I'm going to multiply my a times my c, and that gives me 36. Maybe use the x method or the box method to factor. That's fine. I use the AC method. So I'm basically looking for 2 numbers that multiply together to be 36, but add together to be negative 12. So let's see. I'm breaking down the factors here. 9 and 4. What else do I have? 8, 7. Ooh, 6 and 6. That's going to work. It's going to be negative 6 and negative 6. And it's already looking a little bit like a perfect square, right? Negative 6x plus 9, right? So again, factor by grouping, I take out a common term between these first 2 and between the second 2. So I could take out, let's see, definitely a 2 and definitely an x. let's see, if I take out 2x, what happens here? I'm left with 2x minus what? 3, right? What can I take out from here? It looks like I can take out a 3. And in this case, I'm actually taking out a negative 3 because that's going to leave me with what I want in here, which is going to be what? 2x minus 3. Right? And if you want to prove to yourself that's true, you can put the negative 3, basically multiply it back in. You'll get right back to where you started. So look, now when I factor by grouping, I pull out the 2x minus 3. I'm left with 2x minus 3. So this is proving what I said in the beginning, that this is always the same binomial, just repeated twice. So I can rewrite this as what? 2x minus 3 squared. Okay, and I guess I don't have to rewrite it that way because I'm just trying to find the zeros. So I'm basically just trying to set this equal to 0. So when, let's see, 2x minus 3 equals 0, right? So now I'm solving for x. So let's see, I can add 3 to both sides. And I have what? 2x equals 3. And then I can just divide both sides by 2. Divide by 2, that gets the x. Remember, I'm trying to solve for x. I'm getting the x by itself. And we already know that we just have one solution for this, since we already know that we just have one real root. So this is my root. So in other words, if I were to graph this, this would be the vertex. And since this a is positive, the vertex would be at x equals 3 over 2, and it would open upwards. So this is a great strategy, finding these roots and x-intercepts and stuff like this for graphing these. You can use this to graph them. Okay, hopefully you're getting the hang of it by now. We'll do one more example. I'm going to jump straight into the discriminant, b squared minus 4ac. My b in this case is negative 3. So I have negative 3 squared minus 4 times 1 times negative 10, okay? So what does this give me? 9 minus 4 times negative 10, that's negative 40, but minus negative 40 is plus 40. And this equals what? 49. Okay, so I have a positive discriminant. That means what? I have 2 roots, right? So if I set this equal to 0, I can solve, and I'll have 2 roots. So I'm going to set this equal to 0. I'm going to solve for my 2 roots, and I think I can factor this. I'm looking for 2 numbers that multiply together to be negative 10 and add together to be negative 3, and I believe that's going to be negative 5 and positive 2. X minus 5, and we can check this answer. X plus 2, let's check it. If I FOIL it back out, I get x squared plus 2x minus 5x. That gives me that middle term, and that gives me the negative 10. Yeah, we're good to go. This is still equal to 0. So what do? I have 2 things being multiplied equal to 0. So that means either this is 0 or this is 0. So I basically just set both of them individually equal to 0. For this one, I can add 5 to both sides, and I just get x equals 5. For this one, let's see. So that's 1 root, right? Then I have x plus 2 equals 0. I can subtract 2 from both sides. That gets the x by itself, and that gives me x equals negative 2. So these are my 2 real roots for this quadratic function. All right, hopefully this video helped. Get some more practice if you need to. Lots of practice problems. Yeah, if this helped, hit the like button, hit subscribe. If you still have questions, leave them below. If you have suggestions for more videos, let me know. And keep flexing those brain muscles and keep making those brain gains.